This is the You Are Business Network.
Welcome to another episode of Science in the Wild. This is your host, Gary Riccio, and I'm here with my co-host, Nathan Roman.
Hey, Gary.
And today we have Dr. Tom Stoffregen as our guest, and I'll make a few comments before we get into it. But first I want to point out that, over the last few weeks we've been spending a lot of time with guests who are representative of the demand side, people who employ scientists or work with scientists who themselves are not scientists. And we have actually been focusing a lot on video games, which might seem strange, but just to reemphasize, video games are one of the largest and fastest growing markets in the world today. About to pass 100 billion in annual revenues this year and growing by about 20 billion per year. So it's big business, and it's very entrepreneurial, and the role of science is evolving very rapidly in the development of video games and understanding the various uses that they can have. And as you've seen over the last few shows, we've addressed social and medical effects of video games. We're going to be having somebody in the next show who's going to talk about the use of video games for rehabilitation. And today, however, I wanted to have Tom Stoffregen on because of all the news surrounding the recent acquisition of Oculus by Facebook, and pumping $2 billion into that startup is, everybody is expecting, is going to really be a game changer, no pun intended, for virtual reality, immersive experiences where you're immersed in a virtual world, and nobody can even really imagine what all the manifestations of those products and the associated businesses are going to be. But one of the issues is going to be about the experience that people have in these artificially created worlds, and to what extent can they make you feel uncomfortable, even motion sick. So the reason we're having Tom Stoffregen on is that he has studied motion sickness for 25 years. And the other reason why I think it's going to be really interesting to interview Tom today, in the context of the shows we've been having over the last 2 months, is that, from time to time we've talked about what scientific quality looks like when you go outside the laboratory in the wild, so to speak. What does scientific quality look like when scientists are collaborating with people in business, people outside of academe? And we haven't said a lot about it, but, we have generally referred to the importance of scientific community, of peer review, and of obtaining convergent evidence over time to balance the rigor you can get in the laboratory with the relevance that you can get by working outside the laboratory. Now, implicit in that is the idea that scientific quality, how scientific quality is judged, is a function of how long an individual investigator stays with a particular problem. And there's lots of things that factor into the esteem that a scientist might have in the scientific community, but one of the things that definitely is held in very high esteem is a scientist who sticks with a problem over a very long period of time, over decades even. And we haven't had a chance to address that yet. And, I will try to from time to time in the show, because I think it's very important for the public to understand science as a process and science as a journey for individuals as well as for a community. And I could not think of anybody better than my friend Dr. Tom Stoffregen to talk about this, because Tom has studied a very difficult problem for, as I say, decades. And it is one that is all about things outside the laboratory. So I'm going to hand it over to Tom now to talk a little bit about, just to give a brief sort of summary of who he is and what he does. And, then what we're going to get into is, why motion sickness and how a need outside of academia, outside the laboratory, has really been such an engine of innovation for Tom in his academic career, and how that's related to the journey that he's had across disciplines. So first, Tom, let me welcome you.
Thank you, Gary. It's a pleasure to be here with you.
And tell us a little bit about who you are and what you do.
I am a professor in the School of Kinesiology at the University of Minnesota. I run a research lab here in the school, and I do, broadly defined, I do research on the perception and control of human movement and human physical activity, and the general focus of my work is on the control of the body as a whole. So I'm not typically looking at manual activity or handwriting or anything like that. I'm looking at how the entire body moves. Typically, we're looking at things related to the stabilization of the body and our ability to maintain stable activity as we stand up, as we walk around, as we engage in our interactions with the world. And
so you do research on these kinds of things, and you teach. Yeah, and as a member of the scientific community, because we haven't talked a lot about this yet, Tom, on our show, you also have a lot of responsibilities in a community of scientists. Do you want to tell us a little bit about that?
Well, I'm not sure exactly which responsibilities you're asking about. Certainly, I'm a member of a number of scientific societies, and I do a lot of reviewing for scientific journals in the peer review process. I review grant proposals for funding agencies and things of that nature.
So that's a pretty significant investment of time, isn't it?
It sure can be. I review for different peer review journals. I review 25 or 30 manuscripts a year.
And these can be pretty meaty, and they're not necessarily people who are doing exactly the same kind of research as you, are they?
Oh no, certainly not. The diversity of stuff that we're asked to give our opinions about can be pretty large.
So again, it's a lot of effort and time goes into that, and I'm just underscoring this because I want people to understand how science can only work if there is peer review and it is a really significant time investments of people to take very close look at what somebody else is doing. And it works both ways, right? Because as scientists, you benefit from that really significant time and effort that people put into their reviews. I mean, would you say, Tom, that you've benefited a great deal in your career by reviews that others have written?
Absolutely. It's a two-way process. I accept invitations to do reviews much more often than I turn them down. I very rarely turn them down. And of course, it has to work in both directions so that when I submit anything for publication, there need to be people who are willing to take the time to review it. But I will say that it's actually one of the most pleasant parts of my professional life. I really enjoy reviewing because it gives me an opportunity, an excuse, if you will, to focus very directly and specifically on the actual content of the science. There's no sort of outside influences going on there. There's no administrative issue. There's nobody else to please, but just to take the science on its own terms and give it my best professional judgment. I really enjoy doing that.
Now, there's variation across the disciplines about how reviews are done. In I think the field that Tom is in, it's typically the case that the author whose work is being reviewed does not know who the reviewers are, that the reviewers are blind and so-called, and the person
anonymous reviews.
Yes, and the person who is reviewing the paper does know who the authors are. So that suggests to me, Tom, that, understanding the body of work of the author you're reviewing, does influence your reviews. Would you say it does?
Oh, absolutely. Absolutely. I think not only does that happen, but I think it's completely appropriate, and one of the pluses of the process is that you as a reviewer have the opportunity to go back and look at an author's previous work and see how it led to what they're doing now, and see how the current work fits into the larger body.
I mean, this is so important because, today, I'm very happy to see that there's a lot more scientific communication, science communication to the general public. We've had people on this show who've talked about that, who do that. But by and large, most of what we see are, what I might call factoids, results of science that the general public, whether it's presented this way or not, the general public is inclined to think of these as either, facts or lies, but they're basically right. End products, right? And really science is something that is an endeavor that's continually seeking clarity. It's a companion on a journey. For anybody who's interested in what the science is studying, if you're in business, we've made the point that, when science works well for business, it's that there's a collaboration between people in the business and the scientists, just as there is a collaboration between scientists within a broader scientific community. And, as Tom has just said, even reviewing an individual scientific paper is something requires that you understand somebody's body of work.
Gary, you make a really good point that I carry into the classroom. When I'm teaching here at the university, I always make a very deliberate effort to acquaint my students with exactly what you've said, the fact that science is an ongoing process rather than a list of facts. And I have to say that all too often the students are surprised to hear me say that. That they come into the classroom and they think that I'm just going to hand them a bunch of facts and make sure they understand the facts and then give them a grade, and that'll be the end of it. And a large part of what I've come to do as a teacher over the years is to focus more and more explicitly on having them try and understand that science is a process rather than a product.
Well, you know what? I think I'm going to have Tom back to talk about this specific issue another time, but I'm going to kind of sidestep that issue right now because I think Tom has had such an interesting career. Tom, when we first met, long time ago, you had a bachelor's degree in psychology and had just come from the Kennedy Space Center.
Right.
So, and now you're teaching human movement science at the University of Minnesota. So tell us a little bit about this journey and tell us how it connects with your interest in motion sickness.
Well, after I graduated from college, I went to Florida and got a job by an astonishing piece of luck working as a computer programmer at the Kennedy Space Center. And this was in the years immediately before the space shuttle flew, so they had an orbiter there, Columbia, I guess it was, and they were doing a great deal of testing, validation, all that kind of stuff as you bring a new system online. And I just had more or less walked in the door and got this job. I worked in launch control. All the stuff that you see on television, I was involved in that. It was an amazing experience, and it really allowed me to see a little bit about what space travel was like and what the whole enterprise was, and it certainly made a very lasting impression. So when I got to graduate school, I went to graduate school at Cornell in psychology, and I had to learn the stuff that they wanted me to learn, but I also had the opportunity to think about things of psychological phenomena that were of interest to me, and a lot of the stuff that I had learned about while working at the Kennedy Space Center sort of stuck with me. And I wanted to find. I thought space was neat. Okay, this was a sort of the classic little kid watching the rockets going up and think it's cool. I thought space was neat, and I thought well, maybe I can find a way for my psychology training and my status as a scientist in psychology to have some connection with humans going into space and so forth. So I very deliberately looked around in the existing scientific literature to see if there was any published research on psychological issues, behavioral, perceptual issues of human beings in spaceflight. I found a little bit. There wasn't a whole lot. I found a little bit of there are certain kinds of interesting things that happen in space flight, such as the moon illusion and so forth. But the one thing that really stood out prominently in the existing literature at the time, and this would have been in the very early 1980s, was that a lot of astronauts get very, very motion sick when they arrive in orbit. And this was something that was becoming a serious operational problem for NASA, principally because a person who's incapacitated with motion sickness is not doing their work, and you've spent a tremendous amount of money to place that person into orbit, and if they can't do what they're supposed to do, then that's a terrible cost. So NASA was putting a lot of effort and a lot of money into understanding what they call space motion sickness, and trying to predict it or to prevent it or whatever. And as I say, I saw that was the prominent sort of behavioral science thing that showed up in the literature, and I thought, well, maybe there's some useful connection there, or maybe there's some way I could get involved in that and do something about it. And so that was really the specific origin of my interest as a scientist in the existence of motion sickness or any sort of a scientific approach to it.
So where did you first begin to appreciate the connection between motion sickness and virtual reality?
That would have been during my first postdoctoral fellowship. After getting the PhD from Cornell, I spent a year as a postdoctoral fellow at the Flight Simulation Laboratory at Wright-Patterson Air Force Base in Dayton. And again, this was in the mid-'80s, the late '80s, I guess. And at that time, the U.S. Air Force was certainly in the forefront of people developing very high-end, state-of-the-art flight simulators with very large, high-resolution, computer-driven displays and so forth. And so I had the opportunity to be around some of these systems and to see how they worked and to sit in them myself and so forth. And sure enough, one of the things that was reported very, very broadly by pilots, by trainers and other people who use these very expensive, very complicated flight simulators was that they made people sick. They had a terrible tendency to make people sick, which in this case would interfere with the training mission and would mean a lot of money and a lot of time was being put in, and they weren't getting out what they wanted from it.
Tom, at what point would you say that your own research on motion sickness really became your focus?
Well, I'm not sure that I would even say it's my focus right now. It's certainly the area in which I publish the most. Over the last couple of years, I don't mean to hem and haw too much, but I'm not sure that I'd be comfortable saying it's my primary focus. But in terms of the experiments we've been doing in the lab the last few years, if you count up the publications, then yes, I suppose that would count. The momentum on that really picked up certainly within the past 10 years, and it's been picking up steadily. Within the past 4 or 5 years, we've published a quite large number of these studies. Now,
and it's taken you to other kinds of domains, right? So, from space to virtual reality to...
We started out, yes, the original interest was in space flight. It then moved quite naturally to the vehicle simulators and the virtual reality stuff, and from there it was a very small step to move into computer games and video games in general. Just recently we've gotten into mobile devices. We just published a study looking at motion sickness among people who play with iPads, and it's branched out in some very strange ways as well, unexpected ways. I'll give you 2 examples. First of all, I have a student who just is completing his PhD work now, looking at motion sickness that can happen with classroom technologies, because you have some of the same virtual reality-ish kinds of things going on nowadays in visual displays in classrooms that you have in some of the video games, and sure enough, we were able to demonstrate that some of the sort of high-end classroom visual display technologies that are now being heavily marketed and emphasized as educational tools have the unfortunate side effect of making people sick in the classroom during the educational experience. So that's fairly alarming.
Yeah, we don't need another reason to make kids sick in the classroom.
No, we don't. Although I suppose it keeps them from being bored. The other one, which perhaps is even stranger, is that we have been doing a series of experiments now looking at head trauma resulting from I should say head injury resulting from head trauma in relation to concussion among athletes. So I learned fairly recently that one of the early symptoms of concussion is nausea and vomiting. Very common, not universal, but a very common early symptom of concussion is nausea and vomiting. And of course, no one would call that motion sickness in anything like the classical sense. But I got to wondering if there might be some connection there in terms of the perceptual motor issues involved. And we've been doing some research with boxers in which we measure their bodily control and their bodily movements before they enter the ring, and use those data to predict who is and who is not going to experience head trauma-related motion sickness after a bout. And wow. that is I mean, that's a right turn if there ever was a right turn from everything I ever thought I was doing.
Well, Tom, this has really been fascinating. I think we're about running out of time in this first episode with Tom. But Tom, we'd love to have you back and talk a little bit more about this because, I also want to talk a little bit about in the next time we have you on, the whole immersive virtual reality issue with Oculus and Facebook, and also specifically, how you in particular go about studying motion sickness in ways it's different from what had been done before you came on the scene.
I would be delighted.
Tom, it's been a pleasure. Thank you very much.
Thank you, Gary. It's always good to talk to you.
Okay.
You're listening to the UR Business Network.